Well, uh, welcome to the January 14th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KB0S, and this week I've been cleaning computers, reorganizing my setup. We have snow on the ground here this week, and I think the squirrels and the snow have contrived to get a little water in my feedline coax for my delta loop. So right now, my uh, K9Q radio is using the DX engineering antenna and using it with power. And it seems to be equivalent. So I'm quite pleased with that. But now I got to replace the other coax. So that's it for me. Next on the list is Nathaniel, W2NAF. Go ahead.
Thank you, Dave. I have been in full speed ahead since we got out of January, New Year's, and Christmas break. Um, I was able to get the first semester, so I'll only be teaching one class this semester, which is I'm very grateful for because there's a lot of projects going on. I talked to Christina Collins this week, and one of the things we're going to start doing for the Daisy 2 project is the Thursday morning telecons at 10 a.m., which we've been using more specifically for the Grape telecon. We're going to start turning those into the Daisy 2 management um, telecons. So a lot of the Daisy 2 management decisions, I think, are going to happen at that telecon. And there's going to be, that's where Christina's going to be the chief operations scientist. And, I know Bill Engel usually goes on that telecon. So, and Gary McKeaton's often on that telecon too. So a lot of the people who are doing kind of like the project management sorts of things are going to be over there. I'm also starting to recruit new students for the different projects. So I think I have I have like undergraduate, three new undergraduate students I'm going to be bringing on over the next year. Two of them are junior physics majors right now, so we'll have them for about a year and a half. And a year from this May, they're going to have to write some sort of an undergraduate physics thesis. And one of the students I'm going to assign to the Antarctic project. And so her job is going to be to help figure out how we deploy a RX 888 and or Whisper Demon type of system down to McMurdo Station. I know that we are now in touch with the research assistant who's at McMurdo Station, who's someone I've met before. Her name is Shelly Campbell, and I know she used to be a ham. I don't think she is now. She used to have her novice license, but she's worked at McMurdo for many years in the MacOps section. And MacOps is the communications section of McMurdo that's responsible for making sure that everyone who's in field camps on the ice is safe. And so they typically communicate with the people in the field over satellite, but they also do use HF to communicate with the field sites down there. So it's nice. She has a long history at McMurdo Station and on the ice, I think something like 20 or 30 years. And she has a significant amount of experience with HF operations. And so recently she's shifted away from her Mac Ops. She was, I think, director of Mac Ops for many years. She's shifted away from that, and she's now the research assistant that's going to, help deploy these things. So we'll be working with her. And I think the student that's going to be working on that is probably Rebecca Potter, who she just got her ham license, her technician license last year. Then another student I just started talking with is also junior physics major. Her name is Nina Torman, and I think she's probably going to be the person working on the Daisy 2 US deployment. And her main task, I think, is going to be working with uh, working with Gary to figure out where these new stations are going to be deployed to, and then actually uh, ordering the parts and packaging things up and getting them ready to ship out to people. So I think that's going to be her initial task. And then, for her thesis, she's also going to do some sort of a analysis with the data as well. And the third student is a freshman computer engineering student named Owen Rozansky, and he just got his technician license last last week, and he's I think K the Kilo Delta 3 Alpha Lima Delta. It's a very new call sign. But he's been with W3USR since he pretty much stepped foot on campus, and he's extremely enthusiastic and very bright. And we have a project with the Frankfurt Radio Club, and that project that they're sponsoring is specifically to develop some sort of a visualization of the personal space weather station data to help the contesters and the DXers. So it's a little bit more operational and a little less, science related. But I think we're going to, try to use streams of like the whisper data that Whisper Demon's collecting, and Phil Karn showed the HFDL streams last week. We're going to start having him working on that, and we're going to kick that off with a Zoom presentation to the Frankfurt Radio Club tomorrow night. And I think, that's funded for 1 year, but I'm hoping we can kind of keep developing that over the next few years and use this as an opportunity to get FRC members to coach our W3USR members in contesting and operations, and then use that to also, help educate Owen and come up with a way that, some new ways we might be able to use the personal space weather station to address not just science but actual ham radio operating. So we've got a lot going on there. There's also last week we talked about this Frontiers special issue, and I can put a link to that in the chat here. Jonathan said he specifically got an invitation to that special issue. And let me put this in the chat. And I think he absolutely should submit something to that. So this special issue is called the Heliophysics Big Year Education and Public Outreach Reports. And it's actually being convened by our very own Christina Collins. So she's the one organizing this special issue. And Gareth Perry and Pat Reif, who you know, and you may have also heard of Hunju Connor, they are all topical editors, guest editors for this. So the submission for initial um, summaries, essentially draft abstracts, is January 30th. And then they're looking for first manuscript submissions due July 4th. So I'm planning on submitting one that's essentially what I submitted for my AGU talk, which was basically a summary of all of the different Festival of Eclipse Ionospheric Science projects that we did. And that just kind of does an overview of everything. And I won't get into very much detail about any particular results. I'll just show highlights. And what this will do is this will put a nice paper out that just gives a big overview of everything we did. And then the people who would like to submit more detailed reports about their particular thing, like Jonathan will hopefully do about the VLF project. And I'm asking Steve Serwin to do one about the HFTDOA. They can write papers for their different things. And Kuldeep is going to be doing one about the solar eclipse QSO party. So in case it interests anyone to write a paper on one of the things they're doing, this is a nice opportunity to do so. So I think that's all for now. Go back to net.
Okay. Okay, next on the list is Dave, KD0EAG. Go ahead, Dave.
Well, I have very little to tell about, so I'm just going to listen this evening. Back over to you.
Okay. Next on the list is Scott, N5 TNL. Go ahead, Scott.
Hey everyone. The usual this week, few web updates, bug search, etc. I do have a request. If anyone can advise me on how to properly attribute the Kiwi color map that I stole, I'd certainly appreciate it. And that's about all I've got.
Well, very good. Maybe Rob has some comments on that. We'll let him talk about it in a minute. Next on the list is Bob Strickland, N5BRG. Go ahead, Bob.
Just checking in here, catch up, and don't have anything to offer tonight. Just trying to stay warm from the cold weather we've been having here. It's not as bad as yours, but close. Back
Oh,
I hope it's not too awful. I have to go down to Austin.
Austin,
couple days.
warm. Don't have any trouble there.
Good, good.
okay. And next on the list, we have, Bill Engelkey. Go ahead, Bill.
Thanks, Dave. Well, I've been working on getting all of the parts and pieces put together so that I can import all of the Grape One legacy data and also run plots of those files. There's FL Digi data, and there is a GitHub put together by Christina, and I think some of Nathaniel's code is in there. But anyway, I've gotten it to where I can use that code to make plots that are compatible with what that software creates. And so I'm knitting together all the pieces such that I can make it work like the other uploads. So when I push a file in there and create a trigger file, it will automatically get the file. It will put cross-reference into the database, and it will run a plot, put the plot in the right place so that you can look at all of these observations we have from the Grape One legacy machines and look at the plots and download just like you can with the other, with Grape One DRF systems. And that getting that plotting working was because it was really designed to do a large swath of files all at once, and I had to figure out how to get it do just one and gain control over it and use a lot of libraries that we hadn't worked with before. So anyway, I think I've got that working, and as soon as I can get it to where it works, it's got to be automated because I got 60-some thousand files to put in there, and I've got a plan lined out for a little package that's going to submit the files and create the trigger files, which will allow me to automate the operation of it. So that is on the table for next thing. Also, we got our students back from for our beginning of winter spring semester, and we are going to work on an API that allows you to do bulk downloading of files. That's something that Gwen had requested, and we're just now getting around to where we can get our ducks in a row to go to work on that. And we have to also put together, we have a first draft plan of what we're going to do for the DAISY phase 2, and gotta put some more details to that. I guess we'll talk about that in the Thursday morning meeting, how to move forward with that. So back to Ned.
Okay. Well, next on the list is Clint, K7OEI. Go ahead, Clint.
Hi. Yeah, so been doing more things than typical this past week. Last week I showed a 6-meter diplexer and preamp that got installed this past weekend. So now the RX-888 at Northern Utah is now receiving off 3 separate antennas, one optimized for VLF, the other one for HF, and the other one for 6 meters. They're all being combined, and they all there's no overloads, and they're all set to see the local environmental noise floor. So it's very possibly the only 888 set up properly to receive from 10 kilohertz through and into 6 meters, and hearing everything that can be there, that can be heard. And almost immediately we were able to get FT8. Pretty much every day we get a scattering of FT8 transmissions on 6 meters, mostly from the Midwest and the Pacific Northwest. And there's not as many whisper transmissions on 6 meters. There's some out of Texas that we occasionally hear. The other thing is also mentioned last week that the little Nook computers like the B-Links and all that do have one very serious flaw that should be considered, especially for high reliability applications. One thing we noticed was that occasionally the B-Link we have in northern Utah would just be dead, and we could remotely power cycle it. And what we suspected was happening was the transition of the UPS, which only, if you have an incandescent light up, you see a brief flicker as it goes clunk. We suspected that was the power supply was not riding through it. And when we went up there, we actually flipped it a few times manually, turn off the main breaker, and indeed proved that. Fortunately, I had built a super cap reservoir UPS that I tested it, and I only tested it, and it ran the PC for about a second and a half just on a capacitor under moderately heavy load, just on the tail end of processing. And that made it totally immune to this. But the sinister thing about it was that the computer would get glitched but not reboot. It would just hang there forever. So if you have one of these remote computers and they don't have a battery in them, like laptop, these NUCs use laptop power supplies. They don't have batteries to support them, and they don't have a lot of energy storage because they're small bricks. You better be able to either have it right through something or be able to remotely power cycle it. And we tested that, and it's in there, and I'm getting documentation on both of these projects set up, and now it is absolutely bulletproof. But anyway, used a 3.5 farad capacitor and an ideal diode, and it just plugs in between the PC and the power supply, and it's painless. And unfortunately, everybody I've talked to said I need a couple of those, so I don't know what I've gotten into. Anyway, back to you.
Well, Clint, if you get a design that we can put together, maybe the TAPR store could sell them for you or whatever. And so you don't have to make them all. Next on the list is, let's see, I'm gonna make sure I didn't skip anybody. Dave, W6OQ, go ahead.
Good evening, everyone. Let's see, this week I've been mostly trying to follow the fires across town. Not a good scene. Anyway, I got a little smoke, but things are pretty clear now, and I think it's settling down. Other than that, I'm here to see what I can learn.
Where are you, Dave?
I'm in Los Angeles on the south side.
Outside. I'm in San Diego, so,
So
good luck, guy. Good luck up there.
Yeah, I'm in Palos Verdes. We have like similar, I think a similar, I don't know, we're in an area that the insurance companies think has a fire problem. So
Well, California does that.
my home insurance went up by about 30% this year. And I think after the fires, I don't even want to hold my breath on that one. Anyway, yeah. There we go. Thanks.
Well, stay safe. And next on the list is Dave New, N8SBE. Go ahead, Dave.
Yeah, hi. Good evening to everybody. I missed, I guess, the last couple of weeks. If you guys were still having Zooms during the holiday season, I was in Calgary, Alberta, during between from Christmas to New Year's. So we're back at home now, and But the one major thing there is that my grandson got married in a private ceremony in the living room there in Calgary, and so we were essentially meeting our new in-laws while we were up there. So it was a fun time. Everybody had a fun time. So that's it. I don't have anything else for the net. Back to net.
Okay. Next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. Nathaniel, I was looking at the HamSCI website and it announced the HamSCI meeting up here in March, but there's no other details. Do we have any information about hotels? Any hotel information available yet?
I think they're still working on that. It'll probably be the Robert Treat Hotel. But I think they are still working on those details.
Oh, okay.
I can tell you that the local organizing committee is now meeting every it's now meeting every Friday, and they did post the abstract submission over the weekend. So I believe that link went out over the email, but it doesn't look like they actually posted that to the website yet. So I'll have to follow up with them on that.
Yeah, because I'm going to be driving from Detroit. Need a place to stay. Looking forward to attending it, and I may even be able to grab somebody else to come along who's never been to one, and he's a real science guy, so trying to twist his arm to come along with it. But so looking forward to seeing everybody at NJIT this year. Will also be my first time in the state of New Jersey for anything other than passing through on the way to New York. So with that, played a little 20-meter FT8 over the weekend. The farthest I got was Canary Island on 50 watts. So just that's about all that's really happening. So I'll say 7-3 to the group here, and I'm going to be backing out shortly a little while. So I have to actually get in the car and go someplace. So 7-3 to all. Take care. Stay warm. Hope everybody in California can survive. Can survive, and what else can we say? Good luck to everybody out there. Back to net.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan. Jonathan's mic muted. If he's there. Well, we'll come back to him. Next on the list is Phil Karn, K9Q. Go ahead,
Hi
Phil.
guys, I'm just madly writing down here notes for all the stuff I've been at lately because I've been on a roll. Lots of changes to KNIQ radio, tightening things up, fixing bugs, handling a lot of pull requests, especially from Scott. I now support loadable driver modules, which the users of SDR plays and some other devices may appreciate. I got rid of one of I've cleaned up the make files. Makes are now faster. Let's see. I this was a hack. When I read the configuration file, this is a problem. If you mistype a keyword, was no easy way in the library I was using to detect that. It would just be ignored. So I added a feature where it scans all your keywords, makes sure they're valid, and if they're not valid, it suggests nearby corrections. That was the first time I implemented that algorithm. The configuration files can now be divided up into subdirectories. It will just take all the files and concatenate them in order, so you can manage your configuration files a little more in a little more modular fashion. Let's see. It verifies that an output sample rate is legal, and if it's legal but results in an inefficient FFT, it will tell you that on the log, and it will also suggest the next larger size that would be efficient. I ran into this when I was restructuring my HFDL logging. When I started, I had one instance of HFDL for every channel, of which there are, what, 200 or so? 100 some, I don't know how many there are. And I tried as an experiment to restructure things so that there's one receiver instance, one KNIQ receiver channel per band, feeding an instance of of dump HFDL, which has its own multi-channel digital demodulator, probably somewhat similar to my own. And there doesn't seem to be a whole lot of difference in performance. It works both ways. This might be slightly faster. Can't really tell. Let's see here. Oh, I added the second filter. I wanted to improve the filtering on narrowband signals. And this is hard to do without adding a second one, because otherwise it would slow things down too much. So there's an optional second filter you can add that can also use longer block sizes than the default. So if you're willing to spend a delay, you can make really sharp filters now. That's off by default, but I can show you how that works. I also have output buffering so that, especially for when you have a lot of slow sessions, you won't send a lot of little Ethernet packets. It'll send a few bigger ones. This will probably help Tom McDermott and his problem with overruns. Let's make sure that works. Let's see. PCM record is now in pretty good shape. I put a lot of stuff in for Rob. He's now integrating into Whisper Daemon. Seems to be working well. I want to use it to replace or take the place of PCM cat, PCM spawn. A lot of features in there to make it easy for it to just run programs automatically when a new channel comes up. So you don't have to configure everything channel by channel twice. You only do it once in KNIQ radio. Let's see. It will also record wave files for FT8, FT4, and Whisper that are on, the proper time boundaries with padding at the beginning if you start late, and no drop samples between files. Let's see. Floating point output now works well. Rob is really happy about that. I've begun documentation using Doxygen, which I've not used before, but that's just very, very, I've just started on that. The monitor program can now handle any sample rate, not just one of a couple, and it does it in a much more elegant fashion by using a library. I've restructured things so that packet loss concealment in monitor works really well on Opus. It's remarkable how well it works. 16-bit floats are now enabled by default. Hopefully, there won't be any portability problems. And the ID lookup that gives you a list of all the local repeaters and their IDs, the table is now indexed by PL tone as well as frequency, because often I have several repeaters on the same channel and I want to know which one I'm listening to. So those are all ones I can think of at the moment. I've been very busy lately, but I want people to give this stuff a try.
Sounds like a lot.
Yeah, I've been on a roll.
Very
That's
good.
impressive.
Thank you.
Look forward to trying those out. Next on the list, let's see. Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone in the group. I've been using KE9Q Web a lot this week, trying to sniff out some interference problems. And Scott Newell's extra features, especially max signal capture, have been super helpful. Right now I have the loop inside, and that's quickly revealed terrible limitations. Anytime the central heat clicks on, I get a bunch of overload events in the receiver. And the LED lighting in the new place is great, except when you turn it on, and that causes a bunch of issues. So I've got to figure out how to get it outdoors and disguised as though it belonged here rather than looking like an antenna. So I think colored LED lights and some green leafy material might disguise it. So back to the group.
Well, good luck with that. And let's see. Jim, the K4 BSE has jumped in there. Go ahead, Jim. Well, he's there, but okay. Let's give Jonathan one more time.
Hi, everybody. Sorry about that. There were some very nice natural radio events that happened last week. That was in response to the geomagnetic activity that was going on. There was a bunch of nice whistlers and some periodic emissions, which was really, really cool. And that's actually one of the primary, or should I say personal reasons for running these systems is that observation of these natural radio emissions, because normally you would have to go out into a rural area at all odd times of the night and listen for these. So that's what's so exciting about systems like these, this one, and software like this one, is that you just set it up and it records, and the software actually tries to identify with great success these emissions automatically. So this is just another example of how exciting this is. The other good thing is that the system has been in continuous operation since December of 2021. So still a lot of very exciting things to observe. I was also doing some investigation on some VLF spectrum from back in the summer of 2023. Dr. Birch from Auburn University has been doing some very nice VLF experiments, particularly where HARP emits signals, which inadvertently generates VLF signals. And one of the things that they observed was kind of like a stepped response in the spectrum, where you have individual frequencies that would occur for about 30 seconds. It would start at around 3 kilohertz and then jump to around 4.5, and but on the spectrogram actually looks like a stepped response. And one of the things that they did to successfully to try to detect that was removal of background spherics, and this was in August. So you have the summer lightning in full swing. So it's not an easy task in terms of signal processing to eliminate the lightning impulses. So I was playing around with the spheric blanker of VLFRX tools, and I looked at a section of spectrum, the same time and duration as one of Dr. Birch's spectrograms, and I didn't see that stepped response. So I believe that it's probably safe to say that the system did not receive those signals. I would have to do some more investigation, but those same experiments also occurred August of 2024. So I would have to look at that data. That might be that might show something, but I haven't had the chance to look at that yet. Lastly, Nathaniel, I am going to submit a manuscript summary, and I was wondering how long it should be. They're expecting a paragraph, but I'm thinking maybe something 500 to 1,000 words. I don't know if that's too long. I haven't really found anything that anything that says how many words to submit or anything like that. Okay, yeah.
So if you, I'm actually working on a manuscript summary submission right now, and if you just go ahead and start the process on the website of submitting the manuscript summary, and it will tell you the word limits as you do it. So the manuscript summary is 2,000 words.
Okay.
Now I'm for the paper, the manuscript summary I'm submitting, I'm just submitting exactly what we did for the American Geophysical Union meeting. So the same abstract, I'm just pasting that right in there.
Right. Okay. All right. So 2,000 words, and that's going to follow the outline that we discussed last week, or at least that's the plan. That okay.
Yeah.
All right.
And what's nice is that at this point, it just needs to be kind of, the general idea of what your paper is going to be. Like, if in the process of writing it, it changes a bit, if that's okay. So.
Okay.
Yeah,
all right. Well, then I'll get a cracking on that. One of the main things is my girlfriend was so excited because when she originally saw the email and she seen some of the top editors, she was so excited that someone affiliated from NASA would actually contact me. So
that's awesome.
Yeah.
You have a good girlfriend, Jonathan.
Yes, absolutely. She was so excited, and I just couldn't say no. So yeah, I'll be cracking on this, Nathaniel. I'll submit it to you for review, and well, maybe I'll attach it to, or I'll submit it to everybody, and then and you, Christina, and Gareth.
Great. Yeah, think about who you want as your co-author list.
Okay. Yeah, I was thinking about that the other day. I'm thinking some Georgia Tech people.
And then of course, if you have Georgia Tech people on there, you need to make sure that you go through this and make sure they're good with it too.
Yeah. And yeah, some Georgia Tech people, and you, and I'm not sure who else, but that's the current list right now.
Yeah. I can talk to you about that offline too, and
Yeah.
we have a discussion. Yeah.
Okay.
We
All
we
right,
still
then.
have one more person to call on here.
Okay. Yep. Other than that, that's all I have. Back to the net.
Okay. And next on the list is Rob Robinette. Go ahead, Rob.
Good evening, everyone. Just my activities remain focused on getting this floating point recordings up to the Grape server. So with Phil's help, he both produces the floating point streams and then his new version of PCM records them, and that whole system works. Interesting to me, I think the results, the difference between transcoding from float to wave, um, um, or transmitting float, yeah, and it ends up being about 0.5% more spots if you process the 32-bit float samples. So there's more work there's still a translation going on from float to int and back to float. And so there's an opportunity for a little master's project. Somebody could go into there and investigate the effect of decimation, unnecessary decimation. And anyway, that's about I think that most of the rest of what I'm working on isn't software-wise, doesn't really affect anyone here. The antenna project, Glenn and Elmer, I think, have been especially active. We've all seen the results of Scott's dramatic improvements to the K9Q web package. Glenn, who is professional life was spent doing spectrum analyzers. Glenn is just waxing rhapsodic and says there's no tool out there that gives you this kind of view of the software spectrum. I guess right now Scott's web page up refreshes like 10 hertz. So you see things happening that you don't see when you're averaging over longer periods. Anyway, I'm repeating what Glenn's saying. So that's it. So the antenna project, I think Michael's been away, so we haven't really done much, but Glenn and Elmer are working, N3 AGE, AGE, have been working on the single antenna system. I think Glenn has 5 candidate trial sites, alpha test sites, where he's going to distribute these and go through the whole procedure with the alpha testers. Very intimate. The benefit for us, I mean, of course, if potentially this single antenna could justify its, a lot of complexity in developing and marketing it. But even if it doesn't do that, if we don't choose it in the end, learning through this process how to set up and test and validate and monitor that a site, the antenna hasn't fallen over or the neighbor hasn't suddenly turned down an electric fence or something. All that stuff, we're better learning how to do those kinds of things. And through this process, of course, Michael's intimately involved in this. Through this process, I think we'll be able to have a much higher probability of success and uptime for the DAISY2 network. So that's the main focus for me. So back to Ned.
Okay. Well, I will mention Michael is soon to be back with us. He's been up and dealing with his installation in North Dakota and coming back to Missouri here soon. And so he is actively working on these things. He's just not able to talk on the net tonight or last night or last week. So
But he contacted me at noon saying he was driving home.
yes.
He was on the road somewhere.
So he should be back working on things again soon. And actually, I was going to have him look through my Whisper Demon installation here when he gets back. So anyway, I think that's everybody. So we're open for general discussion.
If I can, I'd like to share something and show you a couple of things real quick here. I have a new Mac computer, which is kind of interesting, but I think this will share like the other one does. Let's see what it does here. So did that work? Or let's see.
We're looking at some redwoods.
Yeah, you're not seeing
Those are sequoias.
How about if I
Sequoias, sorry.
move the
Very
screen over?
beautiful.
For you non-Californians, there's a big difference.
Am I sharing the wrong screen, or you see anything now?
We're seeing a picture
Yes,
with
004Q.
It
Okay,
looks
so
like you caught a bunch of shooting stars.
yeah, okay, good. So now you can see it. So this is I'm participating in a group called globalmeteornetworks.org and operate 4 meteor cameras. I think I've mentioned this here before. And I've got 4 cameras up that are collecting meteors that come in every night. And some folks are watching during the day as well. And so this picture is showing you the star trail through the night. And it also shows you a few airplanes that came through the image and then the meteors that it sees. And also I was in another image, you can see it, but this line through here is my loop dipole that's being used for this project for collecting the RF data that's being uploaded. And this is 100% of the copy during the night. The image above was filtered. So these are all the airplanes and everything, and they have an AI algorithm in there that filters all the things out that are not thought to be meteors. And
Screen out Starlink satellites.
Starlink go through there too. Yes, you see those, and it's supposed to filter those out. And this is the moon. It filtered it out. And if I go down here, this is this is a plot to show you the origin of that meteor group that you're looking at. And so most of the meteors that I saw came from this particular cluster of rocks that are out there in space that came on into Earth. And it shows you a count that comes through. And across the bottom is a calendar, and it shows this is where we are today. And so it gives you some feel for what the concentration of meteors might be. And just about 3 or 4 weeks ago, I was seeing as many as 150 to 200 meteors per camera per night. And so it's pretty amazing. They have a really nice software package that was developed by a large number of people around the world. And it does a lot of things. It's working with real low cost, like $30, $40 Chinese cameras and a Raspberry Pi to collect the data. And it does things like you build a chart of the stars, and this is it. This is how you get started. You locate all the stars and you tell the software if the star is off from where it's supposed to be. So what this does is it builds a correction for the low-cost lens that you have to perfect the imaging. And then these plots are showing you how good your imaging is through the night. But I thought about this when Clint was talking about the fact that he's now picked up the 6-meter band. And I'm thinking that you should be seeing meteor echoes coming through your area also in your recorded reception, which just adds another whole dimension in my mind to the possibilities here. Because like in the UK, for instance, they're building transmitters and putting them up, or beacons, to try to improve their meteor scatter reception. And I don't know how much ionization there is occurring from meteors, but it seems like with large grouping showers like the Perseids, when they hit, there should be some impact that would be noticeable there. So anyway, I wanted to share that with you and just let you know about it.
I have a question. How long is the exposure?
Well, it's a video, so it's running at
Oh,
25
okay.
frames per second all through the night
Okay.
and collecting the data. And the software automatically analyzes the data. It uploads it to this group. What I was showing you was Global Meteor network.org/status. So you could go there and see the meteor cameras that are located anywhere in the US or in the world, actually, and look at the captures that they have. For instance, I went there and tried to look in New Jersey to see if I could see some of those drones that were flying around, but unfortunately there aren't any cameras in New Jersey. This is kind of a voluntary deal where everybody put up a camera. It's not too much unlike what's going on with this group. And so it's sort of hit and miss in terms of where their cameras are. So Clint, you feel like you've seen some meteor scatter in your reception already, or have you had enough time to look at it yet to notice
I mean, I've worked meteor scatter before on 6 and 2 meters, but I haven't been looking. I guess I could stare at the waterfall, the CW, or the digital, the weak signal segment, and see if I see some pings occurring. But
yeah, it'd be interesting just to see if you're.
But I mean, that would be. I don't know how practical it'd be, but I suppose yet another feature of Whisper Demon could be to run FST 144 or whatever they do for recording and detecting meteor scatter pings as well. But that would be yet another project.
Yeah.
We could also analyze the data coming from PSK Reporter. Most MSK 144 signal reports are meteor scatter. We could look at that. We can look at going back 10 years for any day you're interested in.
That's interesting.
I've worked a lot of meteor scatter. You just get bored with it after a while because it's like watching paint dry, but it's fun to do.
Good thing to automate.
Yeah, this system, I don't look at it very often. It's automated and it collects the data, but occasionally I pull it up and stare at it. But it's contributing to the scientific efforts that some guys have going.
Well, you can leave WSJTX running all night, listening on MSK 144 mode on 6 meters, and you'll catch. Also go on the ping jockey. I mean, there's all kinds of traffic. So
actually, it wouldn't be very hard for me to add support for that mode to Whisper Demon, but I'd like to know that there's actually somebody going to use it before it would be a day's worth of work.
Well, in my case, so too, like I said, I have 4 cameras and I have a friend here in the Dallas area that set up 4 cameras in the southern Oklahoma area, and we overlap each other. And a lot of other cameras around the US overlap. And the concept is if a large meteor comes in and pops and makes it to the ground, you can collect the data and they can project where the thing hits the ground within a very small circle. So you could go out and collect meteors.
well, something like this would be an excuse to get the RX888 working on VHF.
Yeah, that's what I thought. It's just kind of another little bonus to connect things together.
There was one thing that I wanted to add. So VLF-RX Tools has a capability of meteor scatter detection. I posted the link in the chat. so what it does, and this could, and this could actually be run on a separate PC, or on the same thin client PC. So it utilizes an RTL SDR dongle, and a GPS. And what it does is it injects a carrier, or a harmonic that is output from the TP2 output of a U-Block's GPS, into the RF input um, of the SDR dongle, and is gated by the pulse per second, and the software looks for that, and that's how it derives, and it calibrates its timing, um, for much more accurate timing and frequency precision. And there are utilities and VLFRX tools that allow you to do meteor scatter, plot meteor scatter, and also plot a meteor ping ping statistics and information, and analysis on individual pings as well. So it's actually quite useful, and that's something that I had planned on getting going, in addition to the VLF systems. That would just be an extra add-on, the GPS box for it, and the RTL SDL, the RTL SDR dongle, and then we could easily integrate that into the VLF thin client PC. So it'll also capture that as well. If anyone is interested, I posted the link in the chat.
Thank you. Nobody else wants to say. I got some comments about spectral monitoring, since everybody seems to be interested in that. I've been thinking about this. There are limits to being able to piggyback on the FFT I'm already doing in KNIQ Radio to do this, and it's pretty obvious if you try to zoom all the way in, you start seeing lots of artifacts. So if people really want this, if they really think this can make a good spectrum analyzer, I'm willing to add a little enhancement to spectrum.c so that when you zoom in, it automatically creates a radio channel, an IQ radio channel, performs an FFT on it using proper windowing and really small bins, and then gives you results based on that rather than just the FFT bins and the big FFT. And this would all be transparent. You know, what would happen when you zoom in, and it would stop when you zoom out. Does that sound interesting to people?
Well, I certainly think it'd be a real unique and wonderful contribution. So,
I mean, Glenn, you say you used to run what, the spectrum analyzer division at HP? Is that right?
No, he was. I think he was one of the key engineers in the spectrum analyzer
Yeah.
division.
Well, I'm tickled that he says that this is better than, I mean, implying it is better than stuff that he built. I mean, I'm actually surprised. I mean,
yeah, it is. It's
the tools are available to everybody, right? I mean, it's the FFT.
I know, but
Yeah.
it doesn't mean that everybody uses them. How long is the this library, the MIT FFT library, been around before? I guess
quite a while, actually. It's very used. That's why I don't
and then I think it was Phil Harmon who talked about this using this technique that you described. I don't know if you or Phil Harmon were first to talk about it, but I've heard that there were talks back in 2017 and 2014 or something at the SDR Academy on this use of this technique, but nobody went out and implemented it until you went and did it.
Which technique? You mean fast convolution for the
Yeah, yes, yeah,
channel?
No,
Oh,
I
okay.
mean, I gather I've been told that that it had been discussed, but nobody gone and really implemented it as a library like you've
Yeah.
done.
I certainly didn't invent the idea. It's been around for a
I,
while. Found old papers described it, but yeah, nobody had seemed to have done it in ham radio. I mean, when I got involved, when I started all this, it was 2017 or earlier, and I was just dabbling with DSP and SDRs, and I'm thinking, well, okay, if I'm going to put some energy into this, I mean, I don't want to just, clone another existing SDR package. What has not been done? And this seemed to be a little niche. Plus, it allowed me to avoid doing user interfaces, which I just have.
well,
I think
I started Whisper Demon about the same time, and saw this opportunity that there wasn't an appliance for Whisper capturing and recording. It was just a sidecar to WSJTX. So that's kind of when I started. So
Okay.
I think
I
your
was
idea, Bill, sounds interesting myself. It would be an analysis tool that people that are studying the radio they built or studying
Okay.
radios might pick up on. The one challenging thing might be the calibration of it, or which you've got
In
a spectrum
principle,
of it.
it's digital, it's math. The calibration should be exact if the front end. I mean, it all really depends on the analog properties of the front end. Um, when it comes to the FFT, though, there are trade-offs here, and you get into the heavy math pretty quickly. But suffice to say that there'll have to be some tuning knobs because there are some fundamental mathematical trade-offs you have to make. For example, the main one is between the width, the frequency resolution, the width of each bin, and the level of your side lobes. So depending on which is more important, you can turn a knob and push the side lobes down at the expense of smearing the bins together a little bit, or you can, if you don't care about that, crank it in, or you can just do longer FFTs, which I didn't want to do for every channel on KNIT radio because that would add latency. And but for spectrum analysis is easy. I can easily block up a lot of samples from much more than 20 milliseconds and analyze those and get very, very precise resolution at the expense, of course, of a lower frame rate. But then people don't seem to want to. 50 hertz is way too fast a frame rate for them anyway. So it's always software, as Tom Clark used to say many years ago.
Yes.
well. I would entirely defer to Glenn about what the spectrum analysis features that are appropriate.
Well,
Uh,
you guys are
I,
using, so you know what's
yeah.
needed. I mean,
Well, it is nice. It is really nice to be able to zoom in to, in fact, with the Kiwis, I zoom in as to, 100 hertz plus or minus 100 hertz mode on the, I think you can get to that on the Kiwi.
yeah,
So then
I do that too. Yeah.
I like zooming in. And so I think the only way to zoom in without getting the side lobe artifacts becoming significant is to change your FFT length, into a long.
Yeah, well, do a separate FFT rather than trying to
Yeah.
do
Yes.
everything by
Yes.
piggybacking on the main one. And
Yeah.
do this only
Yeah.
when you're zoomed in.
Yeah. Well,
Uh,
I think that right now I don't know I was Scott just checked in yesterday, I guess, or this morning, a code that allows you to change the depth of the spectrum and waterfall samples. Right now, each sample point is a float. So there's 600 kilobits of data going from the 9Q, 9Q web server to the client machine, 600 kilobits. And, that doesn't make any difference on the LAN, and there's unicast traffic. But when you're talking about trying to like support 20 DAISY sites, and
right,
you'd like
right.
to log into them remotely,
Yeah,
uh,
performance.
that would
Yeah,
so I think that going from the 32-bit floats to he has the low res mode, which is 8 bits per sample, fixed 8 bits per sample. So that's one fourth the number of samples per second being or the bytes per second being transferred, and it sacrifices the resolution of the samples. They're now only, half
Yeah,
a
but how
dB
many
resolution.
pixels do you have, right?
Yeah, yeah. So I think that I wanted one of the things I was going to try when I get through the uploading of 30-bit float wave files was to try his the 8-bit per wave waterfall sample mode on his server.
Okay.
And others could do it. I'll make it configurable.
I mean,
So
the,
you
the
can,
bigger issue as I see it is the frequency resolution. I mean, obviously you can't have bins smaller than 50 hertz, but it's worse than that because I'm not using a window. I mean, remember, I'm piggybacking on an
yeah,
FFT. I'm doing
yeah,
it for another reason. And that FFT doesn't have a window on it. What that means is that each 50 hertz bin is going to have a lot of sine X over X side lobes on it. The first
yeah, yeah,
are going to be 13 dB down. And
yeah,
as long as if you were to if it zoomed way out, you'll push those side lobes really close in, and so they won't really bother you that much. But as
yeah.
you start to zoom in, not only are you limited by the 50 hertz, it's worse than that because of the lack of a window. So all that stuff can be addressed if I just make this
Uh,
enhancement
yeah.
spec Z.
Well, that would be one of, I always have a few requests in your queue, my queue to you.
Yes, you
And
do. Yes, you do.
uh, but I think maybe Scott could join me in encouraging you to, and if you need even more encouragement, I'll speak to Glenn about it
Yeah.
tomorrow and
On,
get
on a
him.
related subject, what do people think about my secondary filter? I'd like to see people give it a try. It's not really necessary. Well, first of all, I only implement it in a linear demodulator. I mean, the existing filter is good enough for FM. Um, and even there, it's really only important when when you really need sharp filtering, like if you're doing CW or maybe sideband with a strong adjacent channel interference. Um, for just decoding, I don't think you need it because all these digital modulators are doing their own filtering, also with the FFT, with filters that are much narrower than anything I can do. So it also doesn't make any sense there either. But what made me start thinking about this again recently was I added a feature that will allow you to block up the output rather than sending one packet every frame, even if it's small. I give the option of sending, frames, Ethernet packets only every 40 or 60 milliseconds, so that you can send fewer but bigger frames, which is very handy when you have a lot of low sample rate streams, like sideband streams going into Whisper Daemon. And I'm thinking, well, wait a minute. If I'm going to hold on, if I'm going to delay the traffic, I mean, rather than just sit on it, why don't I actually make it better? If I want to do better filtering, I have to use larger blocks anyway. So if you're going to, do that, you might as well, do better filtering while you're waiting. It doesn't seem to cause much in CPU either. I mean, I mean, using top, I can't see the difference because each slice takes so little CPU as it is, it's less than 1%. I'd have to do more careful analysis to find out, just what a difference it really does make. But these small FFTs are pretty fast. But still, I don't want to just do them by default in every channel because most channels won't need them. But I tried it last night, listening to uh, some crowded CW signals, and it is sharp. I mean, you can really make this thing sharp. I mean, it behaves just like the textbooks say it should behave, which is really gratifying. I mean, I can
Well,
side
yeah,
lobes
well,
down to 100 dB if you want, although I think that's excessive.
this is one more example of the subtleties of a receiver, a short, I really hadn't considered the effect of the lack of windowing until you just mentioned it. So there's,
Oh, what do you mean for spectral analysis? Yeah. Yeah.
yeah. Well, in any
You
case,
know what a window is and why you need one, right? I mean, I already
yeah.
use
Oh, yeah.
filter design, but that's a slightly different problem, related but similar problem.
Well, I've come from the analog filter world, and all I can think of is R's and C's, and
Yeah, well, you got the same
the,
issue there, you know.
of course, I know there's the math describes that, and so there's a, um, I kind of bailed out of analog circuit design just about that at that point. I got into writing system software, so
Yeah, especially for things like audio filtering. I mean, digital is the only way to do that now.
Yeah, well, back in 1977, that wasn't.
That's certainly true. Well, it's just
Oh,
starting to appear. We were playing with it at Cornell. I remember when they got their first Fourier.
oh,
It was pretty
you
cool.
you know when well, as an aside, when uh, the Steely Dan were recording the Asia album, um, their recording engineer, called me up and said, "The guys want to create what we now describe as a drum machine. Uh, do you want to create one for us?" Yeah. And I had to say, I know nothing. At that point, I knew nothing about computers or programming. I was an analog circuit guy, audio guy. So that wasn't the smallest missed opportunity by any means in my professional life, but it was one that I missed because I said, Roger, I don't know. That's the engineer. I don't know anything about this. And he said, well, maybe you would want to. Then, but I'm interested. I said, I'm interested. Well, here, go out here and take a class out at this. This you learned about computers at computer stores back in '75. So I went there and took a class, and that was the beginning of my
That
professional
was how it
career.
all started, huh? Yeah.
Yeah, it's all due to Steely Dan in Asia.
No, it's a good album. Still
It's
a
a
good
great.
album. What, 40 some
It's
years later? When did it come out?
ah,
1980?
we went to see them at Montalvo up here about I don't know 5 years ago. Incredible, absolutely incredible musicianship. I mean, it's just the highest caliber. But they were that way back in 19
I know.
77 when
No,
I never met the guys. I was the engineer. You didn't get to meet the talent.
yeah,
Uh, but they recorded on my boards and tape machines. So
cool. Um,
anyway,
so anyway, yeah, all this stuff is doable. It just takes CPU cycles, which are not a problem anymore. And then you had the mathematical limits, basically the
I
uncertainty principle. It's the same mathematics as the uncertainty principle.
well the it would be great to have to be able to zoom in really narrowly, and of course, and to have narrow receive filters without that like you described. But but it isn't. It's only useful if Scott can utilize what you're both the wave waterfall streams and these. I think there's some question about Scott. I don't want to speak for you here, but I think we talked about changing the audio to um, to something else, compressed audio. What is the name of that audio codec you like?
I
Uh,
like Opus. I mean, I've
oh,
been using it now
yeah,
for streaming. I mean, it
yeah.
KNIQ Radio can now generate it natively. I had been using a transcoder, but it was just too clumsy. So it's now is one of those output options, and for stuff you're going to listen to, I highly recommend it. You don't want to try to run digital data through it, although Steve Hicks from Flex tells me they do that all the time. Their radios use Opus, and people run decoders on the other ends, and they seem to work. But I'm more of a purist, I won't use a codec designed for your hearing if you're going to run into a data modulator. But the reduction in bit rate is dramatic. I mean, you can go from hundreds of kilobits per second down to, well, let's see, for FM, narrowband FM, it's usually around 22, 23 kilobits. And then for sideband quality, it's about 15. And Opus you can tell it how many bits to use, but I just say, go ahead and you decide. And that's usually what it comes up with. And once in a while you hear artifacts, but most of the time you just can't tell the difference. It's also good
That's right.
at concealing lost packets, which I can't do in PCM. PCM, you just hear, a gap of silence if you lose
Hmm.
something.
Yeah.
And
Well,
it happens through it because I've used my laptop over Wi-Fi, so I'm multicasting over Wi-Fi all the time, and packets get resequenced, they get dropped. So it was really handy when I was testing all of it. Well, it was a motivation for writing the code and also a good way to test it
oh,
for
good.
resequencing
How's
packets
that?
and making use of the packet loss concealment. I'd like
Oh,
to try Opus over the air. I mean, it would sound a hell of a lot better than any of the DVSI codecs like DMR or D Star. I mean, they sound crappy to me. Um, I got one of these radios sitting here with a little eerie about DMR is that suddenly there's like silence and then suddenly you jump because somebody starts talking and you're not expecting it. And to me, it always sounds like the speaker cone has a rip in it.
Now you say you've been listening to a station on the KFS Northwest antenna.
Yeah, yeah. Okay, the Northwest antenna actually seems to do all right. I mean, I don't know if it
I
proved
pumped up
itself
all
or what, but
I put all kinds of LNA gain in that path to try to compensate
I
for
mean, it's
overall
giving me
low signal levels.
it's consistently giving me the best SNRs on from East Asia compared to all the other three antennas.
I
They're all
shouldn't.
behaving pretty much as I would expect them to behave.
Well, that's very helpful. Thank you.
Okay.
It's
Right now, I mean, maybe it's an
yeah.
intermittent problem, but so I'm still trying to figure out why I can't decode North Korean DRM.
Uh-huh.
I mean, I'm seeing signal noise ratios as high as 20 dB on 16 QAM, which ought to be enough, but it's just
Yeah.
never able to get
The other people, there's an online
other
discussion
people are
of this.
reporting the same thing, and people are
Oh,
wondering whether it's even a broadcast application. I mean, it's a broadcast system, but they might be using it just for distribution to local stations around the country.
it's a data distribution.
And
Yeah.
another idea occurred to me last night. Maybe this is the modern equivalent of a number station.
Yeah.
Think about it.
Yeah.
Wouldn't it be a perfect way? It's got all
Well,
the advantages of any other shortwave broadcasting, but
yeah.
it's a lot faster.
Hmm.
I mean, the Cubans have been using audio modems, run programs to run in your computer, but this could be even better.
I just before we lose Nathaniel, I was hoping, Nathaniel, that you could your colleague could confirm the April dates. Then I can make travel plans. So
Yes, let me send him and we said April 24th?
I think so. That was Thursday. Yeah. It's the week after Easter Sunday. Yeah.
Right, and Easter Sunday is
I'll have to pull up my calendar to get there.
all right. I will send him a message.
It looks like it's Easter Sunday is the 20th, so I think it would be maybe I could arrive on Tuesday morning, the 22nd.
Yeah, I think that would work out really well. And then you could stay like Tuesday through Friday or Saturday.
Yeah, Friday maybe. Yeah.
And then hopefully the weather will be good and you can come up to my house and we can actually
That would be a
do some
major
stuff with antennas.
I would be disappointed if we couldn't do that.
I think we'll bring our rain jackets.
Okay, I don't mind the rain. There
Yeah,
even a
sure.
little bit of cold, but wet cold. Well, anyway, I'm sorry I took a turn there, but I'm sorry to interrupt your flow of thought there, Phil.
That's all right. That's all right. I mean, I pretty much
that's,
said what I wanted to say anyway.
Okay.
I'm busy
Well,
here on
yeah.
make files. Everybody wants to run hardware that isn't already supported. So I said, well, as long as you do the work,
Yeah.
and it doesn't break anything, I'll accept the pull request.
Well, I'm I think as I think I have in my queue to you what we mentioned, the spectrum stuff, and that we mentioned earlier, and let's see, what was it? Oh no, that's a different conversation. I'm running a FFT4W job on a Orange Pi. I'm still have hopes for the Orange Pi as a platform. It absolutely has enough CPU power to run the 888. It's at 64 megasamples. The 888 will not run at 128. The Orange Pi can't. It drops samples.
Yeah.
And it's not so important, but it's an indication of it's a pretty high performance platform. It's just the loss of multicast traffic, turnaround multicast, is the problem, and so that's why I've asked you for the unicast.
That's my next step is to figure out. Yeah, well, I was saying in chat the other night, my thinking is that I may just say, okay, if you set the TTL to 0, just bypass, just don't even use the Ethernet. Just automatically route everything to the loopback because it really doesn't make sense to do anything else with it.
Yeah.
And they make it easier also to run because I've had problems running this standalone, on a machine with a demonstration with no
Yeah.
network.
Yeah.
And even when you're running TTL0, it often doesn't work unless the network is up. Like you got to plug it into a switch with nothing else on it. This maybe work around that as well.
Okay, that would be well good. Well, then there'd be other reasons
Yeah.
to implement unicast. I mean, I would hope that it could be generalized. I could imagine maybe somebody would, a remote user. It's probably a bad idea. The whole KNIQ radio is the right way to talk to the for a home user to talk to your library. So.
Okay.
Good. Well, I hope that, however, what's ever easiest for you. And I just need
Well, it's
PCM.
easiest for me is to do nothing, but
I know, but well, easiest would to get to this. Of course, PCM record would also need to be listening. Um, I
well,
for
yeah,
some,
yeah.
okay, for some reason in my long ago profession when I was more active technically in my multicast, television days. As I recall, you could subscribe to a listener, a client could subscribe to a multicast port, address and port, and however the packets arrived, whether they were unicast, a UDP, or multicast, that the client would get them. It was the client really didn't pay attention to the source. There's no source routing, so if it arrived at its port. And it could, and as I recall, we could set up our listeners to listen on localhost, and the multicast packets would arrive if the even though there was
Yeah,
actually
you
no.
can do that. You mean a unicast packet to the same port? I think that may work.
I don't know if that's a defined behavior though.
Because you just simply you create a listening port, and then the only extra thing you do for multicast is you bind it to an address. But I don't think that turns off the ability to hear unicast. So I'll give that a try. That would be a simple fix for the problem.
Yeah, that was you could just you would on the receive side you would do nothing.
I would
And
probably still like to use multicast addresses in loopback modes only so that you don't have to get all the traffic you don't want to see if there's some conflict, because I group, I group traffic to the same port number to different streams just for that reason to isolate them, right?
yeah, well, anyway, I'm sure you'll make a good choice. It's you know the problem.
Yeah, yeah.
Yeah,
I've been working with this long enough now. I think I've worked out most of the kinks in the multicast stuff.
Yeah.
Um,
Well, as you've seen that it does impose some burdens on people who home networks, especially a lot of people are unfamiliar with the issues of multicast routing. So for standalone systems, it really is nice if
it's
they
an
don't
important
have to.
special case, when everything's
Yeah.
inside the same system.
Yeah. Well, anyway, if we can get that to run reliably, then we have a much lower cost Daisy 2 deployment package, lower power, lower cost, lower size.
Okay.
So that's how this little project, the unicast project, relates to the overall subject goal of these meetings is support of Daisy 2. So
Okay.
seems like pretty quiet night.
Yeah. Oh, I want to comment, I've changed my mind about ChatGPT. At first, I thought it was a joke, but it's been getting a lot better lately, and it can very often answer quick questions. I think you've been using it the same way. I'll say, rather than having to go through a bunch of references to find the answer to a simple question, it can very often give it to me. Now, it's often wrong. It's not always right, put it that way. So you got to take everything it says with a grain of salt, but it very often does give me the right answer, or at least point in the direction of the right answer.
Yeah. That's how sometimes it's incredibly useful. It's given me a whole a bash function that I could copy and paste and just rename the variables. It's
The longer the answer, the more likely that something in it is going to be
yeah,
broken. You got to
yeah,
get
yeah.
really quick questions with brief
But
answers, and then
but I use it kind of as a help desk. I mean, I have a problem right now is that the WireGuard VPN system that I use to connect to the for the encrypted and protected connections to Whisper Daemon sites. Uh, I need a VPN connection to our droplet, and I've been using WireGuard for that. And when I have my new Mac upgrade, WireGuard opens up, it just no traffic flows through it. So I just showed the error message, copy and pasted it into ChatGPT, and it came back with some pretty intelligent suggestions I hadn't thought
yeah.
of. You know that
And it actually, when I show it a piece of my code, and it actually makes pretty
yeah,
good suggestions on things I might have overlooked. And what
uh-huh.
really gets me is that it can look at my program and it sees what I'm trying to do. I mean,
That
that
is
blows my mind. That part of it blows my mind. It can actually understand the context of what I'm doing. It can see what I'm trying to do, even if I've done it wrong.
how long are these code blocks that you give it?
Oh, I've been giving it chunks from K9Q radio. Usually like, a couple functions, maybe
Uh-huh.
one file. Usually
Yeah.
while I'm writing it, and I
Yeah.
say, I
You
just
give a
read
whole
this. What do you
file? You
think?
give a whole C file to it?
Well, or just a piece of it, the function I happen to be
Oh,
working on.
yeah.
Say, okay,
Oh.
I just wrote this. What do you think? And it makes actually some helpful suggestions on, oh, you should probably check for this case too, and I can see you're doing this to do that, but, have you considered this? And that's kind of, getting kind of eerie.
Yeah. Well, I'm it is a little eerie, although I still feel like I could kind of see that it's a machine behind there.
Oh, yeah, it's
But
definitely a machine, but
yeah, there isn't any true understanding, but it is remarkable what it can.
yeah, and it's
Uh,
getting better.
yeah. So I have kind of have that chat GBT window open all the time and sitting over there. And when I what's the argument to this command? Well, I want socks to do this, to
Yeah,
take
yeah.
a line of floats and output and do gain normalization, and blam, it gives me the whole socks command line, and yeah, I could look it all up and test it and so on, but boy, I can do that um, so much quicker. And the other thing that it did for me this recently was compression. I was using it. Introduced me to FLAC. I heard of it, but I didn't know what it did. And of course, it does a wonderful job of compressing the int files, but it does nothing to these float files.
Yeah, well,
And,
we talked
but
about that.
so I presented this as a problem to ChatGPT, and he said, "Well, have you?" I said, I want to compress, losslessly compress 32-bit float wave files, and what's the best solution? And he said, "Well, you can use FLAC in general purpose, but it doesn't work. But there's something that natively does it. Something called WavePack." Which
Vaguely
utility
heard of, but I hadn't really paid attention to.
I had never even heard of it. So it's exactly what we need. We get 33, well now about 37% compression on average um, of the 32-bit wave files. So they go down from what are they there? I think a minute long file is it 6 or 8 megabytes per minute of 32-bit floats, and it compresses them down to 5.5 megabytes. It's still the int files are half the size and get the same compression ratio, so it's still double or triple the size of an int wave file compressed
Yeah,
loss.
because you're trying to compress noise. It doesn't
Yeah,
need
yeah. So there's
noise.
yeah, but it does. I'm
Actually,
surprised that it could.
the best
I,
way to compress your signals, the best possible compression for your signals is to extract the data from them and throw the bits away,
yeah,
throw
yeah.
the wave
Well,
away. That's the
yeah,
best possible
yeah,
compression.
yeah. But that means you understand what you want to extract from the data. because you're throwing away anything else. You're treating everything else as
Right.
noise.
Well, it is, right? It's unimportant.
Maybe there's something else in there that you
Unless you
want.
want to just log for later debugging.
Well, that's kind of, I think, the philosophy. My understanding is that that's why the DAISY servers are getting WAV files. They're not getting conclusions about WWV. They're getting, 24-hour long WAV files.
Yeah.
And so researchers
Yeah,
can
if
go
you don't know
back at later
what
time.
you're trying to do, then you keep everything. You don't-
Yeah. So you have to keep
I
everything.
understand that. Yeah.
Yeah. So I was thinking that, that to extend that, um, that that there may be a reason people want the full 16 kilosample size files, and you can't upload those, but the Whisper Demon sites, given that you have a contemporary sized external hard drive, you could put a 4 terabyte or a 8 terabyte little 2.5 inch drive on the Orange Pi and record, keep a month's worth of full resolution
Oh, I
sample.
know. Yeah. I mean,
And so that a researcher says, oh, there was a giant flare on May 16th, and oh, wait a second, I can get it from a dozen DAISY sites, recorded that, and they still have the full bandwidth recordings.
yeah.
Ask them, a mechanism to ask them to upload the recordings, the full resolution recordings that they have, so that there's a way to look in with high
Yeah.
resolution at
You're just
events.
going to keep it locally. I mean, yeah, the bits are pretty cheap. I mean,
Yeah.
I,
Well,
I've been recording all the local FM channels for years now, and each year it runs less than a terabyte, which is really
yeah.
nothing anymore
Uh,
with
Yeah,
Opus.
well,
And I was using unnecessarily high bit rate too, so it's going to go down.
yeah, but there you have long periods of complete silence, right?
Well, yeah. Oh, that's true. That's true. Yeah, I have
So,
12
so, so,
different.
so
Although with that's a problem with Opus with WAV files. One of the nice things about WAV files is that uh, if silence, you can just skip over that part of the file and it'll play back with silence, but it won't allocate any disk blocks.
that's
With
great.
Opus, it has to be inside of an odd container, and you can't do that for silence. You have to emit packets that contain encoded silence. How to
Oh,
do that? That was a tricky part of PCM record. If you look in there, you'll see all that stuff. But when there's a
I
pause, I will actually generate Opus silence packets and pad them out. Now,
didn't look at
if the channel stays quiet for 20 seconds, then it just closes the recording and it edits off the 20 seconds of silence at the end. But it leaves the silence in the middle because I didn't want every single transmission to be a file because when even during QSOs on a repeater, the carrier often drops for a few seconds and I wanted that natural cadence to be preserved. But after 20 seconds of silence, which seemed like a good choice, I closed the file. And you can always just grab all the files, throw them at VLC, and play them in order if you want.
Well, I'm doing very much the same thing in Whisper Demon on the Whisper Demon Grape stuff. That because there can be outages at a receive site, power outages or whatever. There may be periods of a day or longer, well, within a day, where there was only part of the day that was recorded. So before uploading to the Grape server, Whisper Demon goes through and validates all let's see, how many, I forget how many packets. Uh, there are 1 minute files. How many minutes are there in 24 hours? It's 24 times 6. What?
1440.
Yeah. So there's that. Yeah, that's right. 1440. So there's 1440 files and 1 minute long now compressed WAV files. And so Whisper Demon goes through and validates all those files, make sure that they're in the right, that every minute has a file. And if it doesn't, if it finds a minute is missing, it creates a soft link to a silence, a 1 minute long silent file. So
Yeah.
that so if you have gaps of an hour or 2 hours, you'll still get a 24-hour long recording uploaded, but there'll be, these long gaps where in this case these are synthesized with silence
Yeah.
files, so they're highly compressible, and
Yeah.
so I think anyway, that's the strategy I've used all along for the current Whisper Demon Grave from the int files, and I'm using the same strategy with the float files.
Okay.
And
Yeah, I mean, even with Opus, I just stopped recording using up any disk space after a certain amount of silence has gone by.
yeah, yeah.
But
Well, I think that just as one of the major reasons for the floats was so I could go through and normalize those 24-hour long files. If there was a different AGC being applied each minute, that then I'd have to go through and have some metadata to tell me that and adjust when I created the final output file. But by having floats, I can do the normalization. Well, don't have to do any normalization.
yeah,
They it just
yeah, dynamic
eliminates
range of a float's pretty huge by radio standard, even by radio standard.
yeah, it would be interesting. SOX, and I was surprised that a number of utilities natively include support for these compressed WAV file formats, and SOX understands both.
Some better than others, I mean, the
Yeah, yeah.
ones that aren't heavily used aren't necessarily
Yeah.
buggy.
Well, SOX is, I think, pretty much the center of the Linux
It
audio
is.
processing world.
It is.
And so it seems to have excellent support for both the FLAC compressed files and for these new wave. I forget. Anyway.
Yeah, but for some reason, the Linux version of SOX by default doesn't support Opus, which is really annoying. The version of SOX for Mac OS does, so go figure.
That's too bad. No, I didn't. It would be.
I mean, you can just pipe through the Opus encoder, but still, it's annoying.
Yeah. Well, it has been easy. This wave compression thing that I found a utility really has simplified that, and I'm getting to be able to streamline Whisper-Daemon a bit as a result of going through this exercise of going to floats. So
okay,
it's been again, thank you for implementing all that stuff for me. So,
yeah. My make final update. Oh, symbolic link problem again, probably. Yeah. Well, never mind.
Yeah, is there, if you get to a point where you want to test it, I've stopped using Whisper Insights from using the code you checked in since.
That's okay, because I commit pretty frequently, and sometimes I have to rapidly do another one to fix something I just broke. So
well, you didn't really break things. It's just that those libraries weren't, that libsample library wasn't present. And I've got Whisper Daemon users they're using Debian, which I probably would work with yours. I didn't test it there, but I think I had sites that are running Linux, Ubuntu 22, or some other Mint or something, and they didn't have that library, and so that's why I had to stop. Broke a bunch of people's. They did a get pull of Whisper Daemon, which specified your top of tree, and your top of tree wouldn't compile on there.
Yeah.
So all I had to do was just I fixed it. I specify that commit from that Sunday right before you checked in the lib sample rate.
I do think hard when I add another dependency, but sometimes it just solves a problem so nicely, like lib sample rates, perfect example. I've been up converting sample rates to 48 kilohertz by just replicating samples, which is really, and only works for certain sample rates. And then when I use lib sample rate, it just solved the problem. I can now listen to anything, including very high sample rates, although she won't hear them. But
I understand, and you tested where you could, and it just turns out that there's other places where it didn't work. I encounter this all the time with Whisper Demon releases. You walk through, you think it's work. You have 4 or 5 alpha systems, and then you think, okay, I've got it, and check it in and make it main trunk, and bam, for the next 2 weeks, you get people calling. It doesn't work. It doesn't compile, or it doesn't run, or it's not doing something. And I have to, and I go out and find out, oh, on this system, it works differently, or the Linux is slightly different. So uh, that's one of the hardest aspects of the dependency, library dependency stuff.
Now everybody wants to use a
Yeah.
different flavor.
Yeah.
I thought the Raspberry Pi would make things easier. I can always just say, well, look, if it won't run in your Linux machine, go get a Pi. At least I know that one.
Well, I wish the Pi 5 could. Some people seem to be running your code on the Pi 5. I couldn't get it
I
running
am.
on Holger's. You're running it. What's wrong with the what's
Well,
wrong
I'm
with
running a
Holger?
Pi 5 with an AirSpy because I have a lot
Oh,
of.
well, no, I'm talking about Pi 5 for
Oh,
the
okay.
888.
Yeah, I mean, the base code runs just fine. I'm using those 70 centimeters because I'm listening to like 250 channels and I need
Yeah.
cycles.
Well, I'm just saying that people keep buying Pi 5s, and I have to tell them they're not going to work with the 888, to my knowledge,
Yeah.
And the Pi 4 works fine with that AirSpy HF at KFS, so there's no problem there. Speaking of which, there was the sample rate issue that it was
Oh, yeah.
recording.
I'm wondering whether maybe that's why they don't recommend that 912 kilohertz sample rate.
Maybe their USB driver can't support it.
Also, well, and it's probably not the case, but also that works out to a non-optimal FFT block size. Now, that would probably not explain drop samples. It would, lost output, yes, but the samples will continue to be read.
Yeah.
So maybe there's a problem in the firmware in the AirSpy HF, or maybe
For
just
some reason, I thought Steve Sykes, I've been working with KD2OM, is the one who's trying to get this working, and he still hasn't. I've been running now. I'm running a wisdom calculation on his OPI. It's been running for 197 minutes.
Yeah, you can never predict. I have now, by the way, so because I am having to generate new filter sizes on the fly, for things like my HFDL monitoring and for sample rate, all that kind of stuff. I'm now having to generate plans, other non-standard sizes on the fly, and rather than just require you to do them all manually, I now just do them in line if the size is 16K points or less. Now, this may cause some delays the first time, but hopefully it will only stall the one receiver channel thread, which you're changing anyway. The other one should continue to run. In fact, I put in feature to drop real-time priority while it's doing that, and then in real-time priority after it's done.
Can you change in the fly the use a different microcode in the library? If a new plan comes in, do you have to restart the whole receiver?
You have to restart, because,
okay.
It doesn't reload the plan. I mean, I suppose it would be possible to do that, but it's usually not a good idea to be quite that dynamic. I mean, if you break it, everything breaks.
Yeah. Okay. Well, that's fine. The warning lines you put in. Steve had he's an example of, he's a fairly reasonably sophisticated technically in IT, and he didn't know he didn't know, or he didn't look at the your radio D logs, and
I'm trying to
that's
put
where
useful data there.
you did. I mean, you put out exactly. It's very nice. I cut and paste what you put out, and cut and
I keep
paste
thinking
it.
about automating that, but I'm not sure I want to start large compute jobs automatically.
Well, and what is the effect if you run the
and
FFT platter
right.
while it's running other things? I make sure that nothing else is running on the computer.
That's probably the best.
Yeah. to
Yeah.
ensure that,
Papers.
and I kind of like to see that the kernel doesn't move the planning job from one core to another, which typically it doesn't if you don't stress it. So I think that doing it that way gives an optimal chance of good results.
Yeah.
But
I
but
haven't
but
looked at the wisdom code, but I mean, if they're smart, they could see whether they've been preempted, and then
yeah,
restart things. I mean, that would explain why it takes so long sometimes. I don't know. Or maybe it's probably just because they have so many different possibilities to try. Other times it's
yeah,
surprisingly fast.
yeah. I know. Sometimes they come back in 5 seconds and it'll have done them all, and you say, how
Well,
does
if you
it
already
miss
did
it?
it, it'll come back instantly, but I see
Yeah,
many talking about that.
yeah. But anyway, I've had it returned very quickly. Maybe it was only missing one, a short one, and so. But yeah, we just reached 200 minutes of planning time on this. So on this Orange
Well,
Pi.
hey, only have it done once. It's not your time.
No, no, thank you. I could just sit here. I have a terminal window open on the left. So yeah, we have anyway. That's that's my support call. But Steve was fairly technical. He didn't either missed the to look in the log file, or didn't know what it meant. Or didn't think to. I think more likely he just didn't know to look, and that's probably meant that perhaps I'm sure you've documented it, and I know Clint described this process in his documents when he
Yeah.
created a year ago. And even so, a fairly sophisticated user didn't he missed that it
Yeah,
needed
I've
to
been
be
putting a
run.
lot of this stuff just because, hey, I trip up on it too, so it helps me as well, having to
Yeah,
figure out
yeah,
what FFT size is or whether it needs WSDN to be created. Also, mistyping a keyword and then suggesting what it should be. I figure the more time I spend on this kind of stuff, the less time I have to spend
yeah,
user
yeah.
requests.
I probably should have Wisteria to go take a look at this after it starts up Radio D and go look at the in the syslog and see if there's this notification and put it out to the user on the Whisper Daemon command line, the terminal command line. So at least there's some hope that they know that something is suboptimal. Because Steve has been, I think, struggling trying to get his 9Q and web system up for several days, if not a week, so far unsuccessfully. So I said, I just go install Whisper Daemon and make it run on his Pi. It's running on the Pi. If if you, I don't think you need an environment, but if you wanted to, there's an Orange Pi at KFS you can access that has
Yeah.
a 888 on it. So yeah.
Yeah,
So
there's a lot of little gotchas in this dynamic loading stuff, but I've been trying to run it now on all my machines, at least make sure it compiles the links, and
hmm
it's actually working pretty well.
yeah.
So maybe this will take care of the headache of the SDR play support. People keep having.
Yes, 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 yes.
I also got rid of a couple of spurious makefiles. There's no more makefile.debug and there's no makefile.py. Those are all folded into the main makefile.linux.
Hmm.
There's still a separate one for Mac OS, which I haven't yet revised today.
Yeah.
A lot of work on
I
it for Linux
I
makefile.
I haven't looked at your make files. The make file my last familiarity with make files is from I think the 1980s or something, and so it's be like trying to understand a foreign language to look at a make
I
file
worked
from
with
the.
the guy who invented Make. It was Mike Lesk. He was in
Uh-huh.
Belfast at the time, and he came over to Belcore with me when that formed, and that's been a very long time, and it's a very wonderful. It is a wonderful tool. I mean, it certainly has its glitches. It can be
Oh
pretty.
yes, yeah.
One of the more annoying things is that spaces and tabs are not the same. You learn that, it
Uh,
drives you
uh,
nuts. You're looking at the screen that looks just fine, and it's telling you there's no separator on this line, and you
yeah,
move the cursor around and discover, oh yeah, some of these are spaces, some of these are tabs. Now, why the hell do they do that?
yeah. Well, every every programming language has its quirks.
Well,
I mean,
that kind of thing is
but
really.
yeah, it is.
I've run into
It,
so many times now.
that's an invisible difference, and
Yeah, that's
that's.
something that could probably drive a beginning program out the
I,
wall.
but there's a tool that you just retab a source code though, and you can go through the whole file and just
Yeah,
yeah. I
There's
mean,
also a programming language called white space.
yeah.
White space.
If
Oh,
if you can
where the
imagine
keywords
what
are all
that is.
different amounts of white space.
Yep, different types of white space.
Oh
So
God.
every
Oh
character is a
God.
comment, except for like tabs and spaces and carriage return.
It's, oh, that's great.
Oh God.
Um,
It's not like the obfuscated C contest.
Yes,
Some
yes,
of those, I mean, when that contest started, I thought about entering it. And then I saw the first entries and I said, there's no way I can compete with this. No way.
yeah.
I got better things to do.
yeah, it's, yeah, it's hard enough creating things. Uh, that's a challenge enough for me.
I mean, I've been programming in C for like over 50 years now. And I try very hard to write code that is not obfuscated. So it's just
Yeah.
like,
Uh,
fingernails on a chalkboard.
Well, if you look at my bash code, you'll see variables that are sentence long variables, where I'll describe exactly is with underscores, of course, between the words of the that I can remember when we used to, to be as brief as possible with variable
Problem with
names.
those is you can mistype them.
Yeah.
And the shell doesn't, you don't have to declare variables in the shell. So if you mistype it, try to dereference it, it'll come up.
It's
You won't know why.
Well, there is every shell script I write starts with set-u, which says treat a undefined reference to an undefined variable, uninitialized,
Was an error. Oh,
as
okay.
an error and abort.
All right. All right. Good.
And there's another one that I don't use, but there's another one where you can tell it, don't wait to the end of a pipe. Okay, if there's multiple programs in them, one of them, the first one that fails, abort the whole thing and return an error from the first one. Otherwise, if you have a series of pipe together, a series of, PSAUX pipe to grep,
Yeah.
well, if you do that, if PS fails, the return code for is actually what grep says, and grep says I didn't find anything, zero.
Well, yeah,
Returns
because pipelines are always started from right to left.
Yes, well, anyway, it aborts, says everything was okay. I just didn't get anything, and so there's no error returned.
Yeah, because
Even
it
though
read nothing.
but
Yeah.
yeah, but PS did fail. It had a system error, and
Yeah.
yeah, and that got lost. So there's a
Yeah.
command to bash for that. There's a bunch of things that I put at the front of every bash program I write too.
I also turn on as many compiler warnings as I can. I turned on
Yeah.
basically every warning,
Yeah.
extra warnings, and I'm proud of being able to get rid of all those in my code on multiple platforms. But there was one that came out and a piece that I didn't write. I think it was a USB fragment that one or the other. I mean, I don't know if it was probably the air spot. No, what was it? I think it was the RS 888. Anyway, it comes up with one arcane warning that is probably spurious. So I started using some pragmas to try to suppress the warnings. I said, suppress unknown warnings. And it came back and says, sorry, I don't know what I'm giving you a warning that I don't know what unwarning warnings mean. And I asked ChatGPT about this. Apparently it's familiar with the problem. It actually gave me conditional code for all the different GCC and C line to be able to turn off these warnings selectively without turning them all off.
Yeah.
I couldn't believe that.
It is, well.
Yeah, I was trying to suppress the warning about the unhandled, unsuppressed. You know what I'm trying to say.
Yeah, I know what you're saying. Yes, I know exactly what you're saying. Well, I fortunately I try to abort on any error, but of course, unlike C, Bash is a lot of the lines are parsed, but they're not executed. So there's lots of possibility for execution time errors.
That's right.
And that's I think the
That
greatest.
is one of the big drawbacks of interpreted languages like the shell that I get used to with C. That I know if my program compiles and links, then I've actually gotten a long way. I mean, a lot of problems are bypassed at that point. I mean, there may still be runtime errors, but at least all my symbols are resolved for one thing.
Yeah. Yes.
All my variables have been declared.
Yeah. And the
all
only
the arguments
solution
matched.
if when you're writing a bash script, the only solution, it's not a solution, but the way the workaround is to check in, run things frequently.
Oh,
You
yeah.
know,
Sure.
just, don't make too many changes before you try to
Yeah.
run
Well,
things.
I'll remake if I change a comment, I mean,
Yeah.
it's always
Well,
make.
yeah. Well, I have to rerun, okay, because I don't know runtime variables that don't
That's right.
abort generate an exit unless that line is executed. So I try to go through and artificially exercise every code branch in new
Right.
code,
Well,
but
that's what code
that's
coverage
really hard
tools
to.
are for.
Oh, I know they don't
Well, for C, there's static analysis tools that'll, first of all, see whether it's even possible to reach all of your code. Compilers will often do that for you.
yeah, yeah. Well,
They
I
do now.
the Bash does not offer that, to my knowledge, doesn't offer that. But these are, I mean, I get, as I say, it's the right tool for what I think it's the right tool for what I'm doing. It's completely inappropriate for a whole bunch of applications like what you're doing. Uh, but it's still the I could write this in another language. I could go and try to learn Python, but I don't think I'd get much. I'd have to, I wouldn't learn much or get new functionality, or even much increased speed or less CPU burden than I get now from Bash, because so little of the code CPU cycles are actually consumed
Yeah.
by
And it's more
the
important
Bash.
actually to just make it robust and to
Yeah,
catch common errors.
yeah, yeah.
I mean, when I
Well,
make a change to my code, I often push it out and compile on a whole bunch of machines that I control, not
yeah,
because I'm going to execute it there, just to make sure I haven't run any weird compiler differences.
yeah. Well,
Or compiles everywhere.
yeah. Well, and the I do what I can, with that's why I say I'm not out of alpha testing yet because I haven't gotten my 4 or 5 core test machines running all the functions of version 3.3,
Yeah.
and and I it's not it's not uploading to Grape. That's I have to do that next. But boy, that uh, you know the compressed WAV files. I was caching stupidly. I was caching the WAV files that came in, and then having a daemon that would compress them and into long-term storage. It's just completely unnecessary.
Yeah.
I'm going to cut out, and those you have chastised me justly for a number of TempFS file systems that I create. So I'm gonna get rid of 2 of them, and
Well, I
yeah,
understand your reason for using them. It's just, you can overdo it.
yeah. Well,
Also, the fact that they don't support things like external attributes that would otherwise be extremely useful.
yeah, that's
Yeah.
we haven't really solved that problem, but I
This
don't really need to solve it.
God here it knows a lot more about the wave header than I do, and I don't really want. I mean, from what I've seen, it looks really ugly, and I'm glad he's doing it, not me. So,
Yeah,
if there's
yeah.
some other way I can pass you a parameter rather than changing a wave header, I would rather do it.
I think, I don't. There's no. The only thing has to do with the overload counts, and I get them from my calls to meta dump, and I wrote a routine. It's you have to spawn off the meta dump, and then do this loop
Yeah,
issuing
that should
kills,
that shouldn't be necessary. You know,
and that I would it be nice to have just a timeout in meta dump, but because otherwise it'll sit there and do
oh,
like a DNS lookup, and it'll sit there and wait
yeah,
for long
that's
periods of
that's
time.
another annoying, long-standing problem is
Yeah.
necessary
So,
timeouts and multicast. I mean, that's supposed to be fast, and yet very often I'm having to wait a few seconds because it's trying to resolve both an IPv4 and an IPv6 address when all I need is the IPv4 address, and there's no
yeah.
going to be any answer for the IPv6 query. I mean, why do people do that? It's
Yeah. Yeah. It's
unnecessary.
well, they're thinking of their use case, and not thinking about ours. But the that was a routine that an approach that was suggested to me by ChatGPT. I spawn off rather than issuing running the timeout command, which interferes. I think ended up interfering with MetaDub. For some reason, MetaDub didn't want to run under a timeout. So I asked ChatGPT for a suggestion about how could I go about running this, and I think I even specified no, I couldn't have specified metadub. Anyway, and it came back with this, well, spawn it off and issue a loop on kill, issue a kill. I didn't know that kill -1 is a way to test to see if a ID is active.
Oh yeah.
So
Well, actually,
I,
kill zero, I think. Kill minus
that's a,
one is HUP, is hang up signal, which can
I was anyway. I think that's what
kill minus
that's what
zero.
I think well, I have to go look at it now. I thought it was, but anyway, it was issue a kill, which is I was running. I ran into another problem with PS, um, pulling to see if I don't know, Radio D or something was running, and if you run PS and give it a um, give it a PID, sometimes it'll hang for a very long period of time. The PSs would hang.
Yeah.
And so I was testing to see if, some daemon is running a PS, and it was hanging on me for 10, 20, 30 seconds. So I had ChatGPT said, run PSA, and then pipe it to grep and grep for it. And your PSA is always going to guarantee it'll dump all of the things and the grep will always, terminate.
Yeah.
So, I've learned, I just mentioned two things programming things I've learned from ChatGPT that I didn't think
Yeah.
of.
Yeah,
So,
it's helpful for giving you hints. You still have to,
yeah.
do the work, but it
Yeah,
very
it's,
often
yeah,
gets you unstuck and pointed in the right
yeah,
direction.
yeah. Anyway, that was I think we've so driven everyone away because we
I
haven't
am
been
in,
talking about radio stuff. If Nathaniel, if you're still hanging out, I don't know what talking about programming languages
Well, what
is the way to keep you awake.
I'm actually sitting here. I'm trying to put together. I'm having all my research students send me their availability. I'm trying to build out a schedule of
Okay.
when I can meet with them each week. So I've just been compiling all of that into a
Doesn't
spreadsheet.
Google Meeting or Microsoft's equivalent do that for you? Here's find a meeting time.
Doodle used to be really good for that, and then they started changing what they're doing a little bit, and the free tier doesn't do it well anymore. And I looked at the Microsoft tools, and it didn't seem to do what I wanted. So
Ah,
I'm
huh.
I am looking for a better way of doing
I
this.
give it to ChatGPT.
I
You
know
really try
what,
it. That you
but
might be surprised.
when there's another, I mean, I also kind of want to look at it because there are certain students I can have meet with me at the same time because they're talking about similar topics, and there's like kind of stuff like that. So
You would be. I give it long multi-sentence problems, and it comes back with answers.
yeah. Now,
That it says
do you
because
use
you want to do this and this. Yeah, okay. Then
do you use a paid
but
version of Chat? Do you use a paid version of ChatGPT or do you use a free one?
no, I use a free one. Don't I
Really?
use yeah.
Yeah. Oh.
Yeah, try it. You may get nothing useful, but you could try it out and take 15 minutes and you would see whether it was useful to you.
Yeah, I should definitely use it more in my workflow.
I'm told that now I haven't tried this, but people say if we're doing like diagrams, flow charts and block diagrams of graphic charts, you can that they use ChatGPT to generate them now. I don't know if that's true, but if that's the case, that would help me a whole lot. I hate drawing block diagrams, learning those tools.
Yeah.
Yeah.
Yeah, my
Yeah.
presentation is pretty ratty because I really don't know how to use modern presentation tools. And when I try, it's always so incredibly tedious drawing boxes.
Yeah.
Yeah. If you have any occasion to experiment with ChatGPT's ability to generate graphical things like PowerPoints and so on. That would be interesting. This is maybe this is wishful hearing on my part. Maybe I just we all know the problems with directed reasoning. So this is anyway.
That
Okay.
sounds really good.
Okay, well, if maybe we did help you out on something you're working on, or
I will take a look.
wasted more of your time. Uh,
No, no, no.
okay,
It's good listening to both of you. I appreciate it. So
okay.
I
Well,
hope that you do well. I did. I will talk to you soon then.
yeah, good. Okay. So is we done? Is anybody else have anything?
I gotta go eat.
I think I'm ready to retire. Clint, are you? You've said almost. I think you commented a little bit during the. Anything going on that we need to know about? I haven't gone out to KFS at all, so I can.
Not really. I'm getting ready to. I mean, Friday I'll head south, and not come back to Utah for a week and a half or so.
Where are you going?
Well, spend a week at Quartzsite, and then a few more
Oh,
days at various friends in
yeah.
Arizona.
Quartzsite. That's
It's camping. You wouldn't be interested.
I don't think
Hamfest
so.
happening in Port Site. Some guys here have been talking about it.
Well, yeah, I mean, it happens every year about this time. So, I mean, I mean, before COVID, it was like, maybe 1,200 people in there. I mean, 1,200 RVs would converge, and last year it was just short of 600 RVs. So, on
Yeah.
BLM land. So, I don't have an RV. I just have a spring bar tent, and I dress accordingly because
Well,
I don't need no stinking RV.
RV. Well,
We used to have one. Kimberly got it right about a year before I got sick. So barely. We used it a couple of times and that was it. And we got rid of it.
Yeah.
Well, we thought about COVID. We thought, well, maybe we should get an RV and just go travel around. And I'd never done it, so I didn't think. I don't,
It's certainly
and
not for everybody. My younger brother tried it for a while, but
yeah,
I mean, but it might be better now. I mean, their intent was to be tech nomads, which is
yeah.
More of a romantic notion, I think, than practical.
Right, but this is about 2016, 2017, and they discovered the hard way that no matter what you do for a reasonable price, there's no way to maintain a VPN over a cell phone network or multiple cell phone.
Believe me, I've tried.
Uh-huh.
Starlink might make it easier, but yeah, it's still not like being at home. You get
Yeah,
spoiled by being at home. If you want to be at home, stay at home.
because the big problem is that the cell carriers, once you establish a connection, in the middle of the connection, they can totally change routes and break VPN. So they would bring up a VPN and
I know.
constantly drop and reestablish and interrupt everything. It just
I know.
I think Starlink is now Starlink is pretty good about that. I mean, so I mean, I've heard that it's okay that way, and a lot of people do
It's really,
for Starlink.
really all designed for, web browsing, and anything else that kind of breaks, anything more longer duration than that.
Yeah, where I used to work, I mean, we had VSAT terminals, and some of the stores we supported had cell modems, and even though they were, they got, they could get maybe, a few hundred kilobits or maybe up to megabit per second, over the satellite link, to our facility. But even though they could maybe supposedly would do speed test of tens of megabits on cell backups like Cradlepoint and whatever, they could never complete batch jobs, that required VPNs. They would never complete over the cell network, which effectively meant that even if you did have the cell network, you couldn't run a store entirely over the cell network, because you could do credit cards, but if you wanted to do inventory control, nope. Wanted to do pharmacy stuff, nope, not that either. So, the pharmacies would constantly go down and reestablish. I mean, but VPNs over Starlink, I think, kind of work. But yeah, and for some reason the salesmen, of these other systems, the cell-based systems, would never mention stuff like that.
Of course not.
Yeah, look, it surfs pretty fast. You know, oh yeah, that means it's got to work.
Yeah.
Anyway, oh well.
Well, I've been struggling with my VPN, trying to get it running on this WireGuard. That's it tells me it connects, but it never will pass packets. And then finally I looked in the log file, and it's telling me that it's not timing out on its initial handshake. So it's making a connection, telling me it's connected, but really isn't. And I can't quite figure out. It happened when I upgraded the Mac from the previous version 14 software to the current version 15. And that transition, I lost the ability to have WireGuard VPNs. So I haven't figured out why. And I did, it seems WireGuard support's really, from my perspective, close to non-existent. So it seems to be targeted for people like Tailgate or whatever they're called, who build businesses on top of it,
Yeah.
and or the real IT nerd who wants to figure out all the innards of the IP routing. But I don't know why it's rendered my new laptop all semi useless. I have a new Mac, and because I don't have the VPN connections don't work on it. I can't remotely access sites like yours if I'm not at home. I have to be at home and I got the laptop to be able to travel. So um, it's a mess.
Well, I'll be, yeah, can't help you with that. That's a Brett question. I borrowed a Starlink Mini that I'll be taking down there, and I'll see if that works.
I've got to play with Starlink. I mean, I don't really have an immediate use for it.
Yeah.
But I would like to play with one.
The problem, it'll be interesting. The problem, if there's a problem, what it will be is that there's always so many degrees of sky that myself and 15,000 other people in RVs in the surrounding 50-mile radius can also see. And there's only so many satellites and only so many megabits or gigabits per second that can be handled. So,
True.
and that's what the problem is. I mean, because even though Starlink is not a bent pipe, it is limited if you have a lot of users concentrated geographically, which is exactly what's going on here.
Right. Well, it's not designed for that, right? I mean, that's what
Well,
fiber,
it is designed for that, but not optimized. I mean, there's no way to do that except throw more junk into space.
but not with the satellite. I mean, satellites are just not. I mean, it can never do as well as fiber to a point, right? I mean.
Oh, well, that's true. Yeah. I mean,
783. Good night, everybody.
All right. See you.
Good night, Nathaniel.
And